This is our first look at something called complex numbers. Before the introduction of complex numbers, if you had been asked to do the square root of a negative number, you would say, you can't, it's not real. And that's true, it's not real, but we actually can do it with the use of something called complex numbers. The one piece of information that changes everything and opens up a whole nother area of math is that the square root of -1 is defined as I for imaginary. We can't do the square root of -1 within real numbers, but we're going to call the square root of -1 I for imaginary. And that opens up a whole nother area of math that we can explore. Before complex numbers, if you were asked to simplify this radical, you would say it's not real. And that's still true, it's not real. But with imaginary numbers, we can do some things to this and use it to do other things later. We're going to simplify this radical very similarly to how you would if it was a positive. We're going to start, though, since it's negative, by breaking him up with a -1. Then the rest of this breaking up process is the same as if you were asked to simplify a radical that was real. So I'm looking for two things that multiply to 200, one of which is a perfect square. So we're going to use 100 times 2. And because we're doing square roots, we want x squared. So we'll break this x to the third power up into an x squared and an x. So we're going to do what we can, circle what we can't, just like you would before. But now we have this one little added piece, the square root of -1, which is I. The square root of 100 is 10. 2 is going to have to stay under the radical. The square root of x squared is x. And this x is going to stay under the radical. So coming out of the root is a 10x, but he is imaginary. We pulled that I out. And under the root is still a 2x. This is that radical simplified. It's the same as if it was positive instead of -200. If this had been positive 200x cubed under here, we would have the exact same answer but without the I. The I is telling me that we had the square root of a negative, so this guy is going to be imaginary. Sometimes in our problems and in our answers, we're going to have things that have real pieces and imaginary pieces, and those are called complex numbers. In this problem, I see this -3 is imaginary, and this I right here is telling me the square root of 2 is imaginary. But you see this 1 does not have an I, so he's real. So the real part is that 1, because he doesn't have an I. And the imaginary part, well, let's see, the I is telling me that -3 is imaginary, plus the other imaginary part is the square root of 2. Now you'll notice I didn't write the I's in here. This I is not part of the imaginary term. He's telling me that this -3 is imaginary. So if somebody said, what's imaginary here? The answer is -3 is imaginary. But when we're filling in our answers, make sure that when somebody says what's imaginary, we're just going to put in the pieces that are imaginary, not including the I. Now we've been asked to write this in standard form. Standard form is the real stuff plus or minus the imaginary stuff. So that's our standard form. In this one, the only thing that's real is 1. So I'm going to start by writing a 1 plus, and then I need to put the imaginary stuff. Well, the imaginary stuff is -3 and a plus root 2. But these are not like terms, so I can't put them together. I can't add a root 2 with things that aren't roots. So the way we write this in standard form is we tell the person reading this, I wish I could put together -3 plus root 2 because they are imaginary. Anytime you get pieces of your complex number that you wish you could put together, but you can't, we're going to use these parentheses. And it might be this imaginary, imaginary part. It also could be out here. In this case, we just had a 1, but if we had like a square root of 5 that was real, it would go in here with parentheses for the real part. And we're going to see some more practice as we go along in problems of that. Let's do one more. This one's a little different. It's asking us to take these guys and subtract these guys. Well, you'll notice I have some roots that need to be simplified, so I'm going to start with that. I'm going to go out to the side and just take this square root of negative 28 and simplify it. It's negative, so I'm going to start with the negative 1. And let's see, two things that multiply to 28. How about 4 times 7? 4 is a perfect square, so that's helpful. The square root of negative 1 is I. The square root of 4 is 2, and the 7 has to stay in, so 2i root 7. So let's go back over and rewrite this first set of parentheses with the simplified radical of 2i root 7. Now let's do the same thing on the second set. I can see that I have the square root of negative 18. So we're going to break that guy apart. It's negative, so we're starting with that negative 1 again. Two things that multiply to 18, one of which is on that perfect square list. How about 9 times 2? That'd be 18, and 9's a perfect square. So the square root of negative 1 is I, the square root of 9 is 3, and the 2 is staying in, so we're going to have 3i root 2. So I'm going to come back over here and rewrite this with the simplified radical of 3i root 2. We've got some parentheses to deal with, but these parentheses, especially this one here, means nothing because there's just a 1 out front. Be careful, this one has a negative out front, so we're going to have to take a negative 1 and distribute it through. So let's go ahead and get rid of these parentheses. That would leave me with negative 5. This isn't going to change in the first bit. Plus 2i root 7. But I'm going to take this 1 that's sitting here and distribute him through to this stuff. Now it's a negative, so it's going to make this negative 2 and negative 3i root 2. Okay, let's see what we can put together here. First things first, I see some real things. I see a negative 5 and a negative 2. And so we could put those together. They're the real bits, and that would give me negative 7 for the real stuff. And then when I go to look for the imaginary things, I see 2i root 7, negative 3i root 2. Unfortunately, those are not like roots, so we can't put them together, but since they're both imaginary, I really wish I could. That's where we use those parentheses. 2 root 7 is imaginary, minus 3 root 2 is imaginary, and then we're going to make sure we have an I out here to tell the reader that this is the imaginary bit. If you've written your answer correct in standard form, you will always have just one I in your answer.